Hello and welcome to this tutorial on Linux Unix security model. This is only an introduction to the principles that are used. For a detailed explanation and going into real depth, then please look at the wiki below. Now we're going to start, and the format of this tutorial is a kind of storyboard, and it shows or tries to show typical scenario of what users encounter and how the security model interacts with the user. So let's begin. Here we have a very normal situation. A user trying to do something, open a file maybe, and the operating system says, no, stop, you can't do that. The gatekeepers are there and it's protecting the security of the file and the data, and actually the security and integrity of the operating system. It's a vital role. Now there are three key components which we're going to consider in this tutorial. If you go in depth, there's actually an awful lot more. We're going to look at user security, file security, and although we won't go into detail on kernel security, we'll just mention it enough to know that it's there. Kernel security internals are way beyond the scope of this article. Again, look at the wiki, the link is below, and I go into a lot more detail there. But when I was a kernel developer, my specialist modules included job swapper, task swapper, memory manager, and kernel security and security enforcement up to the ITsec level of CMW. And I worked on a few, actually 3 and 4 versions of Unix, which all went up to a high security level. So this is one of my little pet subjects that I'm quite fond of. Here the user is there, she's trying to open a file, and you can see there are you can see the three components all there, and they all work together, they all interact with each other. There's no one module that is taking complete control, with the exception of the kernel, or as I called it jokingly, the boss, who has the final say and the final reconciliation. But basically you're going to have to pass file level security, user level security, and the boss needs to decide everything is okay for you to see or do something with, interact with that file. So for simplicity, I know there are a lot more, but let's just assume there are 3 permissions. You can read, which says you're allowed to read things, quite obviously. Write says you're allowed to change or modify or write to something. Execute, that means you're allowed to do something with an item. Okay? Now these 3 permissions are repeated several times throughout Unix and Linux security. They're a recurring theme. If everything says good, you get the green light. So user security, you have to pass your user level security. You have to have the read, write, or execute, which is do something with. Then there's file security, and again you need to get the ticks. So you need to have ticks at user, file, level security, then you get the good green light and the door is open. You can go ahead and do things. Now there's 2 more components, and that is called groups and others. Now, an easiest way to think of groups are groups of users. So for example, if you're working in an office, maybe you work in sales, there's going to be more than one salesperson. So there's a group of salespeople, and they can have a common set of permission. So each of the salespeople will have their own individual permissions, which are the read, write, execute. But you can also say, well, actually, if I'm a member of a group, then that group, because we all do certain things in common, we share things between us. And then there's others, and others are basically where they're not part of or don't fall into the other two categories. Okay, but everything you've learnt so far applies exactly the same to each of those components. So here we are. We've got the user, we've got the group of users, file. If all the security checks out, green lights, everything good. Now I'm going to do a series, or show you a series of screenshots just to show you how it looks on a Linux system. I'm going to use some extra commands, and you'll see them on the screen. You don't need to worry about them, you don't need to learn about them, it doesn't matter if you don't know what they do. But I just want to give you a chance to say, if you see me use the command cat, echo, clear or ls, I'm just using that for the purposes of the demonstration, and it's not important if you don't know what they do and you don't remember them. You don't have to learn this slide, okay? It's just so you don't panic when you see me using them, or become distracted when you see me using them. So here's a screenshot, and you can see it's got a list of files there. Most of them are owned by Jeff, and in Unix you've got RW, read write, and X for execute. And you can see that in the left hand column they're bunched. So you've got 3, then 3, and then 3, and that's user, group and other. Moving along, you can see the name of the owner, and in nearly all of the cases here it's Jeff, and I'm in group Jeff. One exception, a big file saying don't touch this, and I'll say for the good of humanity I won't start breaking out into, I think it was a Will Smith song, because that's owned by test, and its user is test and its group is test. So yeah, I'm not test and I'm not in test, so there we go. Now I'm going to try to do things with that file, don't touch this. Now I am allowed to view it, because if you noticed on the other it had R. Well, I wasn't, Jeff is not test as a user, I'm not in group test, so I'm other, and other was permitted to read it. So there you can see, yep, I tried to read it and it let me see what's inside. Oh, that's a no-no. I've tried to change it. It says no, guess what, don't touch this, permission denied. I'm not allowed to, because I'm in other, and other only have permission to read. I can't do anything else, just read it. If I was test as a user, or if I was in group test, yeah, I'd be allowed to do other things, but no. And then you can see test, user and group are allowed to read write and read write, other only allowed to read. Now that's covered the basics. I'm going to do other videos going into more detail, and you'll see that there's all sorts of different notation. Sometimes we use numbers to represent the RWX, and for those of you who are techie aware, we actually use base 8 or octal for convenience, but you don't need to worry about that. Subscribe to the channel. I'm making videos as quickly as I can, or as often as I can, but I am actually still working as an IT person and a consultant. Hopefully my user experience will be useful to you, and I've managed to try to simplify a subject which is actually a very complicated subject. Hopefully see you again soon. Thank you for your time.